few specialty areas that are really infrastructure. So network, voice, video infrastructure, server storage, virtualization, other computing infrastructure like that, mobility, data networking, information security, and then cloud and managed services. So we provide complete solutions on everything that we sell. So assessments, design, sourcing from authorized providers, project management, deployment, and ongoing support. So by being specialists in a few specific areas, we can have folks that are really good at these different things. We've got software-defined storage experience. So here on the screen, I've got a picture of one of the installations at one of our customers. If you look at the top here, so let me get a little pointer. We have Cisco Unified Computing System, so that's 6 blades, and this system is running virtual machines and other applications like that. Then we have 2 storage controllers, and then we have disk shelves on the bottom with a number of different disks. So this is the customer's primary storage, and it's running virtual servers and applications. So we speak from experience where our design engineers and our project managers and our deployment and support engineers all have actual experience doing this. So what's in a software-defined storage system? Well, it includes hardware, software, characterizing the performance of the system, configuring it, installing it for the specific applications and usage, and support. And it's developed, tested, optimized by experienced engineers. So it's not just something put together and software running on any kind of hardware out there. It's really got to be optimized to take advantage of the performance and reliability of the systems. One of the questions that I get for folks that have direct attached storage or all the hard drives inside their server, why even use shared storage? Most organizations have shifted over to shared storage in the last few years, in the last decade. But from a big picture standpoint, it lets you take advantage of more of the disk's space. You can use general file system storage. You can put all your information in one place and then copy it to another place. So you can for disaster recovery. And then when you have all your data in one location, it gives you centralized administration and backups. You can analyze all your data, generate metadata off it, then do e-discovery and other types of analysis. And then certainly for virtual servers, virtual desktop infrastructure, or high-performing databases where you need lots of IOPS or lots of throughput, having the storage spread across multiple storage spindles or in SSDs gives you high performance. So the elements of a storage system, whether you get it from a proprietary storage system company or from a software-defined storage system organization, has a number of things in common. Storage controllers, and those are the devices that interface with outside the storage system as well as control all the disks. The software is really the key part, and we'll talk extensively about that. Hard drives and SSDs, there's use certainly for both spinning disk and flash memory-based systems. The hard drive shelves, the standard protocols that are used to communicate between the hard drives, the shelves, the controllers, and outside the system, and then of course professional services and support. So when I say proprietary storage systems, those are systems like the ones delivered by EMC or NetApp or Dell or companies like that. They're very good systems. They're very reliable systems. They really pioneered the storage system industry. And so if you look at, we'll take EMC for example, they're an excellent company. They have a number of different models of storage systems. And if you take their Clarion, which was created by Data General and then EMC acquired them, it's gone through a number of different iterations and versions. And part of that is because proprietary storage systems, just like software-defined storage systems, are built on server hardware, basically. So Intel architecture, processors, memory, SAS cards, hard drives that are made by the major hard drive manufacturers like Seagate, Western Digital, Toshiba, folks like that. And then standard file systems and things like that. What they add is really a pre-built system that's highly optimized, but with that optimization and reliability comes a high price, both in upfront acquisition as well as ongoing support. So some of the advantages of software-defined storage is that we're not tied to a single hardware vendor. And then if you do upgrade your hardware, instead of having to rebuy the software all over again like we have to do in a proprietary appliance storage model, you get to keep your software license. And instead of buying the hardware, hard drives and SSDs only from the proprietary storage vendor, you can get them from regular supply chain, which brings the cost down. Furthermore, with software-defined storage, you can take advantage of server economics and use the existing generation of servers, processors, memory, and then you can have your own choice for support. Support through the organization that put the system together, like Adcap would do, or support directly from the hardware and software vendors. So it gives you choice. Now, the question you probably have is there enough benefit on performance and reliability to want to take advantage of this choice? Well, let's look at some industry trends kind of to back that up and say, okay, we've seen how things have gone in the past, where might things go in the future? And from my standpoint, the way things have gone in the past is that when a new technology goes out there, it's delivered as a complete package of hardware, software, installation services, support, and that's what's required to give the level of performance and reliability. And then over time, just like people don't buy many mainframes anymore, most people run their applications on servers with a reliable operating system. Or when we first started our organization 12 years ago, it was to take advantage of the industry changeover from private branch exchange telephone systems, the VIA and Nortel systems, which were very reliable but very proprietary and systems. That now most of the phone systems out there are applications running on standard hardware, running over networks. And so you got to ask yourself, well, when is that change going to happen in storage systems? Because if you look at industry trends, it's going to happen at some point. And my argument is it's happening right now. So when we talk about storage software, there's a lot of features that people want in storage software. They want reliable operating system and file system. They want lots of different things to be able to manage the data. So snapshots, replication. We want to be able to access the data in a bunch of different ways. Block, file, and then going forward, object storage. You've got to have performance, got to have reliability. You want to be able to integrate it with hypervisors so that you could do clones and other things like that. And then integrate it with applications like backup applications and things like that. And you would certainly want that software to continue to undergo active development over time. Yeah, there's a bunch of commercial storage software around that does this type of stuff already. So there's a few different versions of storage software that do this. One of the more common features of commercial storage software is there's a number of versions that are based on the open source ZFS. But with commercial software, you get what you'd expect with software, which is support, development, design assistance, all sorts of different things. So ZFS storage software, so let's talk about this for a little bit, because this forms the foundation of the software that I think is the most advanced in software-defined storage, because it adds a number of features above and beyond just basic file system. I mean, you could take a Linux box and turn up the hard drives on it and share the files out with NFS or CIFS or things like that. You could certainly also do the same thing with Windows storage server. But ZFS, its advantage is that the operating system is integrated with the file system. So when you do parity, like RAID 0, 1, 5, or 6, it's the file system's doing that in conjunction with it. So you don't get any data loss. And the system goes through and performs checksums on all the data. So as you store more and more data, you want to make sure that you don't have any silent data corruption, which can happen over time. It's also got a hybrid file system, which it makes for significant advantages in read and write speed. This is multiple levels of caching, and I'll show some graphs on how that speeds up performance later. But instead of just reading and writing to and from the spinning disks and the SSDs, it actually does intelligent caching in memory, in SSD, and then improves write speeds by allowing caching in SSDs of writes. It's a mature system that's been around since 2001. It was developed by Sun Microsystems, and then when Sun was acquired by Oracle, a number of things from Sun Microsystems were open source, including Java and Solaris, as well as ZFS, which is part of Solaris. So this has been an actively developed open source project, and a number of different companies, as you've seen, have gone and developed complete storage software around it. And really, the leader in the field is Nexenta on fully supported ZFS storage software. We'll talk about that a little bit more as well. So it's designed for growth. It's designed for being the file system that you're going to be able to use for decades, if not centuries, because it's built on 128-bit. It uses all the different storage components intelligently. So if there's other types of storage system that comes in the future, beyond spinning disk and SSD, it'll be able to integrate that into the overall operation of it. Because it uses an advanced version of copy on write, it doesn't copy extra blocks of data. It just uses multiple pointers to different points of data. That means you can make snapshots or copies in time of lots of different data, and you don't create lots of replication. So it's really designed to operate for a long time. I talked a little bit about the hybrid storage pool and the caching, and this lets us optimize storage for a few different types of things. So if we look at the hybrid storage pool that I have here on the presentation, you can see that we go anywhere from minimal performance systems to over-the-top systems. So why would we want a minimal performance system? Well, in some cases, if we just want to do backups or archiving or long-term storage, we don't really need any special acceleration on the read or write. So if we wanted to have a few hundred terabytes of videos or video surveillance storage or things like that, we could get a number of nearline SAS drives. So they go all the way up to 5 terabytes these days. Put them in a storage system and operate in a minimal fashion. ZFS would give us an excellent parity. We even have triple drive parity options on it. Then if we wanted to look at other types of systems, one or more common one is the better line there. So we have a number of hard drives. We set up in either a 2-disk parity RAID system or a 3-disk parity RAID system, or even in performance mirrors. We use a lot of DRAM for caching. We use SSDs for further read caching, and then we use SSDs for log write caching for synchronous write. And this gives really good performance. So we can even create all flash arrays using this system, and there's been a few different customers that do that. One of the more interesting designs that we've done for some customers is on a performance system, for the majority of their applications and virtual servers, we use spinning disk accelerated by SSD and DRAM, and then we can create special small flash arrays within the system using 6 to 8 different SSDs, and that way we can set up a very high-performing storage system within the main storage system for their high-speed databases or virtual desktop infrastructure. So it really gives us the flexibility to design exactly what's necessary for your environment. The caching really gives significant performance improvement, and it's pretty intelligent caching. So it does a combination of most recently used and most frequently used, and it puts that into memory. So, for example, right now our controllers have 256 gigs of memory, and almost all of that is used for caching. And when you can serve something out of memory, it goes really, really fast. Now, when things age out of that cache, they go into what's called the L2 arc, which is the layer 2 adaptive refresh cache, and that's in SSDs. So normally we'd start with 200 or 400 gigs of SSDs, but depending on the applications that are used, it may be beneficial to extend that amount of L2 arc, and we can simply add in additional SSDs to do that. And then finally, on read, that information is not available in either the memory or SSD, then it can go to and read it directly off the drive. But we can get really fast performance by using the hybrid storage pool. And then we can also use the economics of the combination of DRAM, SSD, and spinning disk. So we can get a very good performing system at a good price. And we can set up the drives in different configurations. Now, we don't have dedicated RAID cards in the system. All the RAID and parity is handled by the main processors. So we end up putting in pretty fast processors. Right now with the Ivy Bridge version of the processors from Intel, we're at 3.5 gigahertz. And so it goes through and does things very rapidly. So we have RAID Z, which is 1 disk parity, RAID Z2, which is 2 disk parity, and RAID Z3, which is 3 disk parity. But for really fast read and write performance, we'll typically set up mirrors. And that gives us 50% utilization. But again, depending on the characteristic of the application and the requirement of the customer, we can get the right mix of price and size. Okay, so I talked a little bit about how ZFS works. Let's talk specifically how this would look in a product. So our product that uses software-defined storage is called SwiftStor. It's software-defined storage. It's designed, built, deployed by our engineers here at Adcap. It's integrated with different applications, and it's fully supported. Not only is it fully supported from Adcap myriad, our 24/7 support desk service, but also from the software manufacturer, Nexenta, and from the manufacturers of the hardware. Okay, so the storage controllers, like I talked about earlier, they're kind of the main part of the system. And so we use advanced Intel-based servers. So fast processors, everything set up in a dual fashion. You know, this is very similar to how proprietary storage systems are set up as well. The controllers are based on Intel architecture with standard memory and then standard interface cards. If you take a look at the storage system that you may have in your data center now, you'll see a lot of familiarity to the system that I'm describing. And then connecting, so the controller connects to the rest of the system through fiber channel or through 10 gig Ethernet. And over 10 gig Ethernet, we could do iSCSI, or we could do NFS, or we could do SIS. Right now, SMB 2.1 is supported, and we'll be supporting SMB 3 very soon. By using a 2-rack unit high server as the controller, it gives us PCI slot flexibility. So we can do multiple host bus adapters because we connect out of this using SAS, currently SAS 2, which is 6 gigs per channel, moving to SAS 3, which is 12 gigs per channel in the future. Hard drives, in our system, we get those from Seagate or Western Digital. We also have the ability to use Apache or Toshiba drives. Right now, from a performance standpoint, we like to use 2.5-inch drives. And these, depending on the system, can go anywhere from 300 to 1,200 gig drives. And they're about the same size. They're about, I think it's 300 gigs per platter. So by getting up to a 4-platter drive. And these are 10K RPM SAS drives. Some folks in the past, when they were using only spinning disk, would go up to the 15K RPM drives. But we found that really with the caching through DRAM and SSD, 10K drives really provide the best price performance. And then for larger capacity storage systems, we really look to move to the optimal price and size combination, which are the nearline drives that spin at 7,200 RPM. And right now, go up to 4 terabytes. Solid-state drives are certainly integrated into the system as well. Now, not all solid-state drives are the same. A 200 gig drive is not necessarily the same thing as a 2 terabyte drive, and some of them can read and write a little bit faster. So when we use them for write caching, we optimize them for really low latency so that our synchronous writes can be fast. And for read caching, we get them a little bit bigger. And then if we're going to be building an all SSD drive or an all flash array or a small part of the system as an all flash array, then we tend to use the larger drives, like the 1.6 or 2 terabyte drives. And drive shelves. These come in a bunch of different sizes and varieties. My preference is always to design a system that has no single point of failure, so dual controllers, and then the drive shelves themselves having dual hot swappable power supplies and SAS interface cards. And these drive shelves, we find really for 2.5-inch drives for performance systems, the ones with 24 across the front work really well. And then for capacity systems, it really depends on how big of a capacity system that the organization needs. And we can go from small to large systems. It's again a price, performance, and reliability discussion. So we have a few specific models that we use. The standard protocols, these are standard industry communication protocols. So the controller to disk shelf communication is done, like I said earlier, with SAS2 or SAS3. Also with SATA, but we like SAS because the drives can have, two controllers can see a drive at the same time, so it gives us high availability on the controller side. And then the environmental monitoring of the drive shelves, the fans and power supplies and the overall system state is done over SAS as well. It lets us do little things like, okay, if we need to replace a drive, we can blink the light on the front of it so that we know which drive to replace and stuff like that. All those are standard protocols, and all these are basically the same systems used in proprietary storage systems as well. The software by Nexenta really takes the ZFS base and extends it significantly to add usability, reliability, driver support for different types of hardware, and improved iSCSI and fiber channel capability, and then integration of the high availability clustering. So, and furthermore, it's continued development and integration. One of the things that Nexenta has done is done a extension and integration into the VMware Horizon View. So for folks that are using virtual desktop infrastructure with VMware, there's a system that Nexenta has that adds on to the Nexenta store, called Nexenta Connect, that makes it easier to set up different virtual desktop infrastructure, as well as use a software version of Nexenta Store to accelerate the performance of the system. It's pretty impressive. We've got it set up in our lab, and our engineers have been using it for the last few months. Oh, our storage lab, this is part of it. We change things in and out of it regularly. Over on the left, you'll see that we have a Cisco blade server system, and that's hooked up to C240 that's set up with a few flash drives on there. So we can characterize the performance of the all-flash array. We've got a couple Nexus switches there. And then we've got a number of other controllers and drive shelves and things like that. We've done a lot of development, testing, and internal utilization of the system over the last few years. And we'd love to have customers come in and take a look at the system and see what it's all about. But it's very helpful to have this lab running. So the pro services that are part of the SwiftStor, you know, it's certainly possible, just like with any other software out there, to buy the software and do it yourself, but there's a lot of complexity to getting the system up, tuned right, and configured properly so that everything works well. Ongoing operation of the system is pretty straightforward, but we really like to get the system set up and running properly for our customers so they have a good experience. And our myriad support is offered for all the solutions that we sell across our product line, including SwiftStor. So we like to be able to take the first call for our customers and take care of any issues. And in certain cases, we need to escalate that back to the manufacturers as well. But we're really the experts on the stuff that we sell, and we're able to support it well also. So advantages over traditional storage. So I talked a little bit about traditional proprietary storage, and then talked a little bit about software-defined storage in the form of SwiftStor, our product. It's a fully integrated storage system, things that you would expect a storage system to be able to do: reliability of data, high performance, block, file, object access, integration with applications, snapshots, replication, recovery, all those things. They're all offered as part of this system. But you get a lower overall total cost of ownership because the model is built on software running on hardware that's supported by Adcap, as opposed to a proprietary system where you have to rebuy the software every time that you upgrade the hardware. And if you look at the hardware that all the proprietary storage system is based on, it's based on server-type hardware. When we were going out and replacing PBX phone systems, those PBXs were designed to work for 10, 15, 20 years. Servers are designed to be upgraded every 3 to 5 years. That's why you'll see new versions of proprietary storage systems every 3 to 5 years as well. And then from our SwiftStor storage system, we have usually we'll divide it into high performance systems and large capacity systems because we find that customers typically want that. They'll want to have a system that will run their applications rapidly. Even though there's a lot of flash arrays out there, flash arrays are a smaller part of the market for the very high performance. There's still a lot of use for spinning disk at the price and performance level of spinning disk, even for primary storage. And then we see that people want to be able to back up the disk, and then they want to be able to replicate that to another location. So really splitting it up into performance type systems and larger capacity type systems is what we find that works best. So let's talk about how you might want to use your software-defined storage. A lot of customers, they're adding a lot of video surveillance cameras. And they're like, well, I got to store all this video surveillance somewhere. I got to store it for a week, or I got to store it for a month, or I got to store it for 6 months. That's a great way to start with a software-defined storage system. You can see that you would be able to take a system, put a number of large drives in it, set up the software to be able to access your video surveillance system whatever way it needs to access it, whether it's iSCSI or NFS or CIFS, and then just start storing it. And then if you need to have your video surveillance replicated, you can certainly do that. One of the advantages of using a SwiftStor as a video surveillance storage is if you needed to do analysis of that video surveillance, even though it's being stored on nearline drives that are slow, we still have the memory and the caching capability. So actually on read back and analysis, it would move pretty quick. Other things, I mentioned backup to disk, archiving, just stuff that you don't need to have around and available as quickly would be a great thing to do it. Unstructured data, internal Dropbox, document imaging, and all this ends up, in some cases, working with data management software like Commvault or things like that. And certainly Tier 1 storage or Tier 1.5 or Tier 2 or however you want to call it, but we have the performance to be able to do a great job with virtual servers, desktops, databases, online transaction processing. Network attached storage, this is just general storage. I'm sure most of you have this in your organization. You want to be able to integrate with Active Directory. You want to be able to put shares out there on the network. Some of the things that the ZFS software is really good at for doing this is it does deduplication and compression. So when we're doing the RAID in the primary processors, we have such horsepower from those Intel processors that we can compress things, and we can actually analyze the data to see if it's going to help to compress it or not. If it's not compressible, like JPEGs or things like that, then it just passes it through. But if it is compressible, it does it right there in the processor and actually reduces the amount of information that has to go over the SAS cable to the hard drives, and reduces the amount of information written to the hard drive. So it actually does help performance, and deduplication certainly helps as well. Backup and recovery with software like Commvault, I mean, that's an outstanding thing to do. Certainly a lot of proprietary storage vendors have their own versions of backup and recovery and snapshot and replication, but just because you're not using theirs doesn't mean that those capabilities aren't required or that they don't exist. So we have a lot of experience doing that. Video surveillance storage, I talked about this. With one of our customers, we figured out that with their system that they were using, that if they had 100 cameras and that they were running 24/7, and they needed to store 30 days of storage, I put some typical codec algorithms up here, but they needed about 20 terabytes of usable storage. Virtualization storage, so integration with VMware or Hyper-V or Zen Server or Red Hat KVM or the Red Hat Enterprise Virtualization. This is a good system for that. So one example, as I spoke earlier, is a performance system for Tier 1 or primary storage. Here's an example of the system. So it would have a couple of controllers. If we have 82 900 gig drives and a few SSDs for read and write caching, it gives us about 36 terabytes of usable storage. And we can also add in 6 1.6 terabyte SSDs for virtual desktop infrastructure or a high-performing database. This is a fairly common system type that we design for customers. A medium capacity. So here's an example of one where we use multiple 3 terabyte drives. We could access it with fiber channel, iSCSI, SIPs, NFS. If we did 16 3 terabyte drives, we did 4 of those shelves, that gives us 175 terabytes of raw storage, or about 120 terabytes usable with 3-disk parity. And you're saying, well, why would I want 3-disk parity? Well, in some cases, that if one of those 3 terabyte drives fails, the rebuild time on it could take a while. It could take actually 1 to 2 days. Now, ZFS is impressive that it doesn't just copy all the blocks whether they have data or not. Since it's integrated with a file system, it knows whether there's data on or not. So it only recopies data and distributes it out. But if the data is really important, you may want to have 3-drive parity on it. And then here's an example of a large capacity system that we could do. So with 4 shelves, 63 terabyte drives each, it could be, about half petabyte of usable storage. So we can really scale the system up if we need to. So if you wanted to get started with software-defined storage, we're certainly happy to talk to you about it. We have our solution architects, or I would be happy to go over what your specific requirements and talk about how we might be able to address that and give you a comparison against traditional storage. We've got a few different demo systems that we've got operating that we're happy to show either remotely or locally, or for some customers we've run different loads or done different testing, like iometer testing or stuff like that, to show what the performance level is. Nexenta actually has a free trial of Nexenta storage software, and they have a free community edition for less than 18 terabytes of usable. So at my house, I'm running the community edition on an old system that I have with some old hard drives, and that's how I back up my home computers. But you could have a free trial of the full-out system and install it on something that you may have already, or there is even a virtual machine version that you could try. And then you got to ask yourself, when's your storage going to change from being an appliance to an application? You look at the history of different things in the IT industry, and that's happened, and it's probably going to happen to storage as well. So that's the quick presentation that I have. Ashley, is there any questions that anybody's had?
Hey, Ralph, it's Sam. We did have a couple of questions come in. The first one is, what are the biggest advantages of ZFS?
Okay. Well, the biggest advantage is it depends on what you're looking for. But one of them is that because the file and parity are operating together, and the striping is done variable width, and it checksums everything every time it reads or writes, is that there's no data loss. So because in a traditional storage system, there's something called a RAID 5 write hole. You could research that and look it up. There are possible data errors in a traditional storage system. Within ZFS, there isn't. So for cleanliness and long-term storage of data, ZFS is excellent for that. However, it might be important to have very good performance at a good price. So I think in a lot of cases, one of the biggest benefits of ZFS is the hybrid storage system, where it caches everything in memory, in SSD on read and synchronous log write. And so I say write caching. So obviously when something is streamed to the box, it's put in DRAM right away. For a synchronous write, the system has to acknowledge back to the client that it's stored in a non-volatile area to be able to have the client happy that the stuff is stored properly. So what ZFS does is, in parallel with putting it into DRAM, which is volatile, it also puts the information onto SSD. So once it's in SSD, then it's in a non-volatile storage environment. So the upshot of it is, if we, for example, hook VMware ESX over NFS to a SwiftStor storage system, when we turn on the synchronous log write, we see the performance of that system go up quite a bit. And then spinning disk is very cost effective, and so even though there's a lot of press and excitement about all flash arrays, flash, even though it goes down even though it can follow Moore's law in certain ways, that you're able to get more flash memory storage over time as the process technology goes down. There's still 1 to 2 orders of magnitude difference in price and performance on spinning hard disk versus SSD. So I really like the hybrid performance capability of ZFS. Sam, was there another question?
Yeah, thank you. Thank you for that answer. The second question is, can you add a shelf as you grow or a second controller after the initial install?
So yes, you can. In fact, we're doing that for a customer right now. So that's 2 different things. So you can start with a single controller and a single shelf, for example. If you wanted to add a second shelf, the specifics of adding a second controller, the specifics of adding a second controller is we end up configuring it in the exact same way from a hardware standpoint as the primary controller. We install the same exact version of software, and then we cluster them together. And then the way the controllers work in a clustered environment is that there's different disk pools or pools of drives that are organized, and we decide which controller is the primary operator of those different disk pools. And that's how clustering works. So we can actually be essentially in an active-active configuration. In that example that I used where we have general storage on spinning disk that's accelerated by SSD and a small flash array, we would have one controller operate the small flash array, and that would use all of its caching and all of its processors to really optimize that. We would have the other controller operate the rest of the system, and since they're operating clustered in a high availability, if one of those controllers rebooted, those drive pools would just fail over to the other one. So we'd have to be able to have everything continue to run. It wouldn't be as optimal because the controller would then be operating all the drive pools, but it would still be running, which is important in a lot of cases. So yes, we can add a second controller. In fact, we can upgrade controllers as well, keeping all the shelves and data in place. Adding an additional shelf, so we connect to the shelves using SAS, and typically we'll have 2 or 4 or 6 ports of SAS coming out of the back of the controllers. So we can either plug the drive shelves directly into an unused SAS port, or we can actually cascade the drive shelves from one to the other, so by setting up basically a SAS loop. So those are a few different ways that we would add shelves.
Ralph, we did have one more question come in. What host tools do you have for snapshots? The appeal of NetApp EMC is not necessarily the hardware, but the host tools.
Yeah, I mean, the host tools are very nice, especially with their integration into other applications. And so, for example, we might want to use Commvault and have that Commvault application use the snapshot and replication capabilities of the drive array instead of doing it in software. So right now, SwiftStor and Extensa does not have that integration with those applications for those specific things. But there are other integrations, like with VMware, like the VAI primitives, where instead of having to make a clone of a virtual machine by moving the data out and then moving it back in, you can use the native abilities or copying it from one part of the array to another. Those tools are there. Hopefully that answered the question.
That's terrific, Ralph. I think we don't have any other questions coming in at this time. So thank you very much, everybody, for attending the SwiftStor webinar. Ralph, thank you so much for your wonderful presentation. If anybody does have additional questions, you can reach us through our website for information. There's plenty of information on the website about SwiftStor, and we thank you for your time.